All right, what I'm going to do now is talk about the skeletons for assignment 4A. And this assignment is going to give you more experience using the Java executor service and futures. At least 4A will do that. 4B will do some other stuff to be described later. So it'll be the same basic UI as usual with the Palantir and beings. And so we'll be covering the executor framework. You can take a look at some videos here. We'll obviously be covering this stuff in class as well. There'll be a few things you need to do here. I would recommend you take your implementation of the fair semaphore that you did in the Palantir Manager and simply kind of copy that over. So you can reuse that from assignment 3 or assignment 2B. And then you'll have to, for this part of the assignment, you'll have to re-implement various methods in the presenter layer, Palantir Presenter.java, and being callables, which we'll talk about in a second. And you'll have to implement various methods here to do certain things. Some of this stuff will kind of be cut and paste from before, but other things will be new. And then the other thing you'll have to do, and this is kind of fun, and we'll talk about why you need to do this as we get into the discussion about the Java executor framework, you're going to have to implement this cool little helper method called submit all, which will submit a collection of callable objects to the executor service without blocking, and it'll return a list of futures that you can use to get the results back. And this is kind of a more flexible and asynchronous variant of the executor service's invoke all method, which is really cool. But the invoke all method is kind of lame, and this implementation is kind of cool. So you'll see how that works. So those are the main things you'll have to do, and you'll have to learn about a couple things we'll talk about in a second in order to make this all work. So that's the basic assignment. The grad students have to use more Java 8 stuff. You're welcome to use Java 8 stuff, even if you're not doing the grad student assignment. So let's start with being callable. So what the heck is a being callable? So a callable is a variant of runnable that adds the ability not only to invoke something or to call it, but to also get a result back. And we'll talk more about this as we get into the Java executor framework in detail. If you recall, runnable has a single method called run, and that will run an operation in some other thread, or not. It could be in the main thread if you want. But it doesn't return a value. You have to update things indirectly by updating other variables or state or something. So what callable does is callable is like a runnable, but in addition to being able to run something asynchronously, it also has a return value. And the method that callable defines, it only defines one method, is the call method. So if you take a look here, you can see there's a method called call. And that's the hook method that's part of callable. And you can see that callable is going to return a being callable, which is a little wacky, but you'll see why when you look at the rest of the code. So the first thing you'll have to do is figure out what the right return value should be from the call method in order to return a being callable. Hint, it's really simple, but I need to give you something to do here. So that's the main difference. We're going to return a result as opposed to not returning a result, which is what you do with a runnable. Here's the being gazing logic. This is actually quite simple. You just have to fill in this field. It's very simple. I gave you all the rest of the code. Whoops. UI utils. Why does it not like that? Oh, maybe it just needs to be updated. Yes. Let's see. Let's fix that. Import the class. And now it's happy. I'll check that in. And then you implement the gazing count and check and decrement gazing count check. That's all simple, same as you've done before. Here's what we're going to do with, this is the reason why we're returning something from callable and from the call method. This is just a helper method that prints out a string that indicates some information about the being, the ID it was running and what thread it was running in, and so on. So anyway, that gets used. You don't have to implement that. That gets used by the implementation. Let's now go take a look at the Palantir Presenter. So a lot of this is similar to what we had before. One thing you'll notice is there's no thread factory that's being used. We're not having a thread factory in this implementation. We don't have to make any changes in the constructor. I don't think there's any changes required in the start method. So what we do here is we're going to call begin being callables gazing and await completion of futures. Now, unlike the previous implementations, which used things like barrier synchronizers and so on to coordinate with the exit of the gazing threads or gazing tasks, we're going to use a different approach here. And let me talk about that. So begin being callables gazing. What you'll need to do here is create a new array list that will contain the being callables. And then you'll need to create a cached thread pool to run all these callables. So those are the two things you'll have to do in that method. You have to make the being callables, and you'll have to make the cached thread pool, both of which are pretty straightforward. Grad students should use the Java 8 features. There's various ways to do this. You can use generators, you can use ranges, and so on. Most of you were doing that in the last assignment, so that shouldn't be too hard. Here's where things get fun. So there's a method which you'll have to implement called submit all. We'll take a look at that in a second. And what that's going to do is it's going to take each callable in this array of callables, or this array list, which is a collection. And as you'll see in a second, it's going to go ahead and submit each of these to the executor, which is a cached thread pool executor. So cached thread pool will create threads as needed. Every time you make a new, every time you submit something and there isn't a thread available, it'll make a new one. So it makes them on demand. And what's going to happen here, and when we look at the documentation for submit all, you see what it's going to do. It's going to go ahead and it's going to submit them. Now, when you submit something to an executor using the executor service, what it's going to do is it's going to return to you a future to the thing that you're trying to compute. Now, keep in mind what we're trying to compute here are the being callables with the call method. And so what we're going to get back is a future to a being callable. And so the submit all method is going to make a list of futures to being callables, and it'll return that here in this variable to be assigned in this variable called mFutureList. And mFutureList is simply a list of futures to being callables. So the cool thing about this, and why it's better than invoke all, is that submit all doesn't block the caller. It simply goes ahead and submits all the callables and gets back a list of futures to the results when those callables are done. And you'll see how that gets used in a second. All right, so holding that thought for a second, let's go take a look at submit all. That's what you have to implement. So here is the signature for submit all. So submit all, as you can see, takes an executor service implementation, which you'll use to submit, and it takes a collection of callables. And so what you're going to do there is obviously you're going to iterate through the collection. And you can use whatever mechanism you want to use to iterate. You can use a stream, or you can use a for each loop or whatnot. And for each callable in this collection of callables, you'll go ahead and submit the callable. And what submit returns to you is a future to whatever the type of the thing is that you're passing in there. And so you're going to have to make a list of futures, and you're going to have to store the results of submit in that list of futures, and then after they've all been submitted and are then conceivably running concurrently and asynchronously, you'll return the list of futures. So as a result of calling submit all, you'll start everything running in the collection on the executor service. You'll get back a list of futures to those things. And then, of course, as you might imagine, if we go back over here to this code, the await completion of futures method, which gets called after we submit everything, you'll basically have to sit there and essentially wait for all the futures to complete. And we'll talk how you do that, but you could watch the video or take a look at the documentation. So what you'll do is you'll use the list of futures and you'll iterate through it, and you'll basically get the result of each future. And as the results complete, then when they're all done, then you can drop out and clean everything up like we usually do. So what this is going to teach you is how to use the executor service to submit two-way operations, callables, get those guys running, get back a list of futures to the results of those things, and then over in this method, you'll create a thread that will wait for all those things to complete. And that way, we don't have to have anything else like barriers or so on in order to synchronize things.
Is this something like promises in JavaScript?
Very much like, exactly like promises, not exactly, but along the same lines. Yes, that's right. Yep, they're all part of this future pattern. And then down here in the shutdown method, you have to cancel all the outstanding being callables via their futures. So that should be kind of fun. You'll have to figure out how to cancel asynchronous operations through futures, which isn't hard, but something to learn how to do. And so that's basically the assignment shells in a nutshell. Any questions about any of that? So obviously, we'll be covering all those things over the next week or so. But if you want to get a head start, you can take a look at the videos that I reference in the assignment.